Alright, so in this video, I will present some more examples on the of the Laplace transform, okay? Let us pick an example. Example. Find the Laplace transform of Laplace transform of f of t equals to t square. So the Laplace transform of ft is equals to, so integral of 0 to infinity e to the negative st and then f of t dt, right, where s is positive. Okay, so now let us plug in the value of ft, e to the negative st, and then ft is t squared, right, and then dt. So what we do is we'll have to use the integration by parts. You understand that? But before that, what I want to do is I want to write this in the limit form. Limit beta tends to infinity 0 to beta e to the negative st times t squared dt. Okay, so let us use the integration by parts for this. What I want to do is I want to do u and then dv, correct? So u, let's say u is t squared and dv is e to the negative st. So we find out the derivative of u and we find out the antiderivative of dv. So derivative of u is derivative of t squared is twice t. Here the antiderivative e to the negative st over negative s, right? What is the derivative of twice t? It is 2, right? So it will be e to the negative st, the antiderivative, over s squared, and then this is 0. So this will be e to the negative st over negative s to the third. So what we do, you multiply this positive side, multiply this with negative sign, multiply this with positive sign, right? So the integral of this becomes limit beta tends to infinity, right? And then so t times that is t e to the negative st over negative s, right? And then minus twice t e to the negative st over s squared, and then it will be minus again because this times that, positive multiplication, but there is a negative sign, right? So 2 e to the negative st over s cubed. You see that? So what are the limits? 0 to beta. Now let us simplify limit beta tends to infinity. You can write this as, let me write down the minus sign outside, okay? So t over s times e to the st plus twice t over s squared times e to the st. I am moving this down, okay? Plus 2 over s cubed times e to the st. And then again it is 0 to beta, right? So what we do next is we plug in beta and then 0. So let me keep that limit beta tends to infinity, minus sign is outside. So what I'm going to do next is plug in beta for all the t's. So beta over s e to the beta s plus 2 beta over s squared e to the beta s plus 2 over s cubed e to the beta s. Now you do minus, we plug in all those, right? So it will be 0 and then minus 0 and then minus 2 over s cubed times e to the 0, that is 1, right? You understand that? Why these two are 0? When you plug in 0 for all these three, the t in all these three terms, what you do is 0 over non-zero, that will be 0. Again here 0 over non-zero, right? And then you will get 2 over s to the third, s cubed plus times e to the s times 0 is 1, right? That's how you go. So look at this. Similar to the Laplace transform of ft equals to t, you see that when you take beta tends to infinity, this term grows rapidly, faster. So basically this term goes faster, grows faster than this one. Similarly here, this term grows faster than this term, and here this term is infinity. So this will be 0, right? This goes to 0, this goes to 0 as well, because the denominator will be bigger, faster than the numerator. Okay, so this one also 0. So what is left is negative 2 over s cube, but there is a negative side. So what do you get? So basically you get this is equals to positive 2 over s to the cubed. You see that? Positive 2 over s to the cubed. We did Laplace transform of 0 was 0, right? Next we did Laplace transform of 1 is 1 over s. Number 3 is Laplace transform of t is you got 1 over s square. You see that? When there is t to the 1, there is 1 over s square. Laplace transform of t square, we got 2 over s to the cube. You see that? So if you do Laplace transform of t cubed, you will see 6 over s to the 4th. In all these cases, s is positive. Okay, guys? So similarly, if you do Laplace transform of t to the 4th, you will see that is 24 over s to the 5. You will get that if you do. Okay, now how can I generalize this? Okay, so here all the exponents are integer, right? So if the exponent is positive integer, you see that if the exponent is positive integer, then the Laplace transform is Laplace transform of t to the n is basically n factorial over s to the n plus 1. This is the formula. Okay, when the exponent is positive integer, the Laplace transform is n factorial over s to the n plus 1, because you see that this is 2 is, you can write 2 as basically, you can write 2 times 1 over s to the 2 plus 1, right? Here you can write 3 times 2 times 1 over s to the 3 plus 1, right? This one is 4 times 3 times 2 times 1 over s to the 4 plus 1, right? Whatever exponent is here, you start to multiply and go down to 1. Okay, start from the exponent and then do 1 less 3 and then 1 less 2 and so on. Okay, so this is basically 2 factorial over s to the 2 plus 1. You see that? This is 3 factorial over s to the 3 plus 1. This is 4 factorial over s to the 4 plus 1. So basically, when you combine, generalize all this, you can see here that if the exponent of t is a positive integer, then when it is, you can see that if the exponent is 1, it is 1 factorial over that, right? So here 1 is, you can write t to the 0, right? So 0 factorial over s to the 0 plus 1, that will be 1 over s. So it works for all of those. Okay, so this is the formula for the positive or 0 exponent of t. Let me add a small note on this. Okay, what we saw that Laplace transform of t to the 0, that is 1, right? That is 1 over s. Laplace transform of t to the 1 is 1 over s squared, right? And then similarly, Laplace transform of t to the 2, that is t squared, is 2 times 1 or 2 factorial over s to the 3rd. And then what is the Laplace transform of t to the third? Laplace transform of t to the third, t cubed, is 3 factorial, that is 3 times 2 times 1 over, you can see s to the 3 plus 1, right? That is 4. So you see that when you add one exponent, when you increase the exponent by 1, then what is changed? You are multiplying by that exponent. See, when there was 2, it started from 2. When there is 3, there is this 3 extra more than here, right? And similarly in the denominator there was 3, there is 3 plus 1 more s. You see that? So you can write this as 3 over s times Laplace transform of t square. You see that? Because this is basically 3, you can write like 3 over s times 2 times 1 over s to the 3, right? You see that? So how much is that? That is Laplace transform of t square. Okay, so let us generalize this result. What we will do is, hence, let me write the formula. The formula is this. Hence, the Laplace transform of t to the n equals to n over s, and then times the Laplace transform of t to the n minus 1. Okay, this is what we get. So this is a note from the above observation, from this observation. Okay guys, thank you.